Hello YouTube viewers, welcome to my show Rocket Monday. In today's episode we're gonna talk about parachute recovery for a rocket. So let's dive right into it. So first we have to understand who is doing this. Basically Rocket Lab is doing it. You can check my full detailed video here, but let's give you a rough overview. So overview is very simple. It's the world's first battery powered rocket. Now what they do is basically they still have liquid oxygen, they still have kerosene, RP1, and they burn it, but using, instead of a turbo pump, they use motor pumps. So that is what's running from the battery basically. And it is a small satellite launch vehicle. They are not targeting for 20 ton or BFR or anything like that. They are like small vehicle built for small market. So that is the whole idea. And then the question becomes, okay, if they are making such a small rocket, what are they selling? How the heck they can be in business? Well, they are selling access to space for small satellites. Basically at this point in time, electronics have been miniaturized enough that we can make very small satellites, quote unquote CubeSats. And many people want to launch CubeSat, but if they directly go to, let's say, SpaceX or NASA or European agency, they all have to have a very long waiting list. It's like, hey, we are doing this big launch, it has enough payload capacity left that we can tack on. Basically that's what it becomes. Small satellites are always tacked onto it, not like a primary mission that costs a very significant delay. So they have to be like, yeah, 3 years ago I planned my CubeSat to be launched, or sometimes 2 years if they are lucky. So these people want to be like reduce that years time to months. Basically like, hey, you want to put a satellite, okay, we'll start manufacturing the rocket instantly and boom, that's it. Their engine is fully 100% 3D printed. So that's the idea. They are going for the CubeSat market and they are selling access quickly. They are like, hey, maybe there are some other people, let's say NASA will give you for cheaper, or SpaceX will give you for cheaper, because they are getting main of the money from the heavy payloads. You are just tagged on. So it may be cheaper, but because you have to wait for them, it's like, how much is your time worth? So if for the people who want quick turnaround, this is the only option. So why reusable? Because if you have watched the video of the people behind the basically Electron rocket, they are like, the rocket is very small. So flat out making it reusable requires it to make it much bigger, basically a medium launch vehicle. The moment they do that, they no longer will have their price advantage. So flat out they cannot do it. Then what changed? Basically market competition is heating up, because SpaceX has now streamlined their process so much, and their recovery and throughput is so high that they are like, hey, we'll have a custom slot ready for CubeSat launch, basically ride sharing, quote unquote. So now SpaceX, because they have such a high throughput, they can be like, hey, you want to book a CubeSat for us? Yeah, wait few days. Again, not few days, but you get the idea. Like, they have such a high throughput that people can afford to wait. So market competition is heating up. On top of that, this rocket engine is going through the same procedure as SpaceX. Basically they are upbuilding it, upgrading it, polishing it. So they have now bit more, not too much more, but bit more. And now they even have the kick stage. Basically this is like a 2.5 stage rockets. This is a kick stage. This is for either circularizing the orbit or pushing it a bit far. And they have a clever idea. So the clever idea is very simple. Is basically using parachute. Now this is a picture of space shuttle had solid boosters and they were trying to recover it. So parachutes on rocket is kind of simple idea, nothing fancy about it. So this is the problem. Now big launcher companies are there like, hey, we will have an interstage, and interstage will spread around your CubeSat. So they have to do this. Basically they also have to increase their throughput. So they can be like, hey, you go to SpaceX, they will be like, wait for, let's say, 4 months, come to us, we'll get it done in 2 months. So why they are not doing propulsive landing, the simplest thing? Well, they cannot make the rocket bigger. That's the biggest limitation. On top of that, even as of now, as we talk to you, their margin for throughput, it's very little, because you have to understand, SpaceX built this Falcon 9 overbuilt. It was capable of putting 20 tons to low Earth orbit. Almost nothing is that heavy, like literally nothing is that heavy. To give you a context of that, check out the weight of the largest section in International Space Station. Even that is not that heavy. So they overbuilt it. So benefit of that, most of the satellites was 8 ton, 5 ton or something like that. So their booster had more than enough range left to have enough propellant to do a slow down burn and then do a landing burn. They do not have the luxury. You can see this is a person, this is a rocket. It's quite small. So, and on top of that, because Elon Musk is doing this for so long, and there is enough video, people think this is a small idea, but you have to understand it. Even Elon Musk was trying to use parachutes for recovery at first. Then they started to recover it, and how many of them blew up? So it's very difficult to do. It's not something that you can easily do. Compared to parachute, this is like 10 times more complex, not only in terms of mechanics, in terms of software engineering, in terms of timing, everything. It's very complex. It's like we have figured it out, so it looks normal, but it's very complex. Why parachute? Okay, well, there is no other option, and it's old and tested. When I'm talking old, I'm talking really old. Basically during 1960s we were using this, and like we kept using it till very recently. So the idea was, we built a space program, we got the spy satellite. That's the first thing we're gonna do. We got the space program, spy satellites. Now problem with spy satellite, at that time we did not had a way to properly transmit high resolution information. Flat out digital did not exist, and computers were analog, and if they transmitted the signal like using Fox and fax systems and all that, it was so low resolution it would be useless. So the idea was created that satellite will have multiple re-entry vehicles, basically something they will drop, and you will catch it. Now trick was to catch it in atmosphere. Now again, it was designed to survive basically landing into the sea, but idea was you're supposed to capture it before that happens, so your enemy cannot capture it. You will know the exact location and you can capture it. Now Air Force did that in 1960. It was simple, and there's the final benefit. You have to understand, this is traveling at much higher speed because it's coming from orbit. This is not the first stage, this is from orbit. It was traveling at much higher speed. Even in those scenarios we figured it out, the mathematics, the parachute calculation, all that. They would get multiple attempts. Even a normal slow and clunky plane from modern standards will get like minimum of 4 attempts before it touched the water. Again, nothing would happen if it touched the water. It was just like a salt plug will start to basically wear away, and they have 2 days after that to definitely make sure they capture it, because after that the sea water will destroy everything inside. So the idea is there, and this is a demonstration of a video of it here, and I've provided the link down below. So one rocket took something like as high as 4,800 feet, not too far, and dropped it. The second helicopter catched it. Now you have to understand, it catched in less than 2,000 feet. So it is that easy, relatively speaking. You have to understand, like with modern electronics, with modern GPS tracking and all that, it's super easy. We have like and you must be seeing SpaceX trying to do the same thing with their fairings. Now why do that with fairings? One simple reason: fairings are ludicrously lightweight for their surface area. So parachute is the only option. If you can't use propulsion, parachute is the only option. We have been using it from 1970, and this company have already figured it out. It's not from basically Rocket Lab itself. It's another company that's joining hands together. So what is the actual step by step, what actually happens? I provided the video below, you can see it, but you have to understand it's rather very simple. It's not complicated as a SpaceX where they have a deceleration burn, then guidance burn, then final stopping burn. There is nothing like that. They will figure out how to do a orientation change, but after that nothing more will be there, and they will be primarily relying on aerodynamic guidance. Basically they will either have grid fins or something like normal fins to guide the rocket. After that they will the moment they hit the upper atmosphere, they will deploy what we call Ballute. Basically this is a specific type of parachute specifically designed from hypersonic to subsonic speed. Basically if you deploy this and you were hanging on to it, nothing will happen, like you will still fall. But if you are traveling at hypersonic speed, this is gentle enough that if you deploy it, it will not damage you or tear itself apart. So it is gentle enough at hypersonic speed, so it will work. It will keep applying drag. It will slowly slow you down from hypersonic speed to subsonic. Basically you are now below Mach 1. The moment the computer detects, okay, now it has entered subsonic, it will deploy second parachute. The moment this parachute will be deployed, there will be a cable like this will be tugging it. So there will be a long cable. A helicopter is supposed to grab the cable between the basically Ballute and parachute, and they can easily recover it. The main importance here is they do not want to make sure they have to make sure the rocket never touches the water, because you have to understand those things are coming from heating. So it will be quite hot. So if you put something like, let's say, 800 degrees Celsius metal directly into seawater, yeah, you won't have metal left after that. So it's quite simple, nothing fancy about it. It's quite ingenious actually. But again, once we actually start doing it, we have to figure out what is the weather, because they have to deploy a helicopter quite early, and they could have a scenario where same with SpaceX, it's many times they have to cancel the recovery launch because sea was not cooperating. Launch site was clear, but the landing site was not clear from atmospheric reasons and all that. So again, there is a lot of extra hoo-ha that goes into this, but again, this is fundamentally a feasible design, something that can be attempted multiple times and done easily. So I wish them luck. So this was my presentation about basically rocket with parachutes. I hope you liked it, learned from it. In that case, please click the like button. If you didn't like it, didn't enjoy it, I would urge you to press dislike, press it twice to show me your extra disappointment, and please leave a comment because I reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.